Ocean acidification, what it is and what it means for our ocean's future. Ocean acidification is a growing concern for all marine ecosystems in Earth's oceans. The term ocean acidification refers to how the ocean's pH is decreasing due to the levels of carbon dioxide that are being released due to human activity, such as the burning of fossil fuels. In 2023, the global average of CO2 in the atmosphere was 421 moles per parts per million, the highest concentration of CO2 recorded, demonstrating how there is more CO2 in the atmosphere than ever before. Then, approximately 30% of all CO2 in the atmosphere is dissolved in seawater, where the CO2 then reacts with H2O to form carbonic acid, also known as H2CO3, which in large amounts will overcome the ocean's buffering effect and cause a decrease in the pH. Today, the ocean's pH has dropped from 8.2 to 8.1 since the Industrial Revolution and is expected to decrease by another 0.3 to 0.4 pH units by 2100. Understanding the role of geology in ocean acidification is necessary in order to slow its effects. This is because both soil and rocks play an instrumental role in protecting against pH increases. Every year, the rivers on Earth naturally add approximately 500 million tons of dissolved calcium back into the oceans, which will then buffer against rising ocean acidity by reacting with excess hydrogen ions in seawater, thereby neutralizing them. This neutralization prevents an increase in pH, as pH is a measurement of the concentration of free hydrogen ions in solution. So, by reducing the number of hydrogen ions present in the ocean, the rising acidity is buffered. Soils also play an essential role in ocean acidification, as mineral weathering is naturally accelerated in soils through physical processes such as freezing and thawing, wetting and drying. Geologists are also able to study the potential effects of acidification through extracting deep sea cores and studying the layers of rock from which conditions were similar around 500 million years ago. The effect on marine life is also extremely important to know, as all biochemical reactions that are essential for life are essential to small changes in pH levels. Therefore, a small change in the pH of seawater can have large effects on marine life, especially because of the short time span over which these changes are happening. Issues for marine life are already arising. For example, the higher concentration of hydrogen ions in seawater are causing shelled organisms to struggle in building their skeletons, taking energy away from other important functions such as reproduction. Rising acidification will also limit coral growth from the lack of calcium carbonate available. Existing coral structures will also be eroded due to acidity. One estimation predicts that by 2080, the ocean will be so acidic that coral will not be able to rebuild as fast as erosion occurs. Thank you.